So next up, we have Steve Ross. Take it away.
Thanks a lot. I think I'm good. Can you hear me all right? Awesome. Good afternoon, everyone. My name's Steve. Before I start, can we just get a round of applause for the organizers? It's their last talk. I want to let them know that we appreciate all the work they did. Thanks a lot. There's a lot of hard work and prep that goes into this, and this conference has just gone really smoothly so far. So thanks all for your work on that. Let's get right into it. Using data to help teams do their jobs is at the heart of DevOps. If you practice DevOps, you have a lot of data at your disposal. The data-driven mindset is woven into the fabric of the way we build and manage modern IT systems. I'm sure whatever environment you consider to be your production one generates a ton of data. This is a live monitoring dashboard that GitLab publishes on the internet for their service. And on this one page alone, there are thousands of metrics for thousands of nodes. You can keep scrolling actually way down beyond even what I'm showing here. Even before you release, your CI pipelines emit data too. I took this screenshot yesterday of our Jenkins job that promotes service builds from our internal staging environments to our production environment. And it produces details, timing details, and error stats about every build that we do. And even before you build, your source control system produces data. This is my 2018 GitHub commit history, and I'll see if you can tell when I left on paternity leave during that year. There are actually entire companies devoted to selling products that analyze GitHub data alone for understanding team dynamics and for code quality. And if you don't believe my anecdotal evidence, maybe some really big numbers will drive the point home. Facebook's internal analytics data warehouse stores about 300 petabytes of user data. Circle CI runs over 30 million builds per month on their platform. GitHub served up 70 million commits last year. So in every place that DevOps brings together different teams and technology tool chains, it produces huge data sets that we use every day to make our jobs easier. This data has become business critical for most IT departments. And it's not just DevOps practitioners that have noticed this. Datadog just had their IPO. Thanks for sponsoring the conference. And there's a bunch of other companies where investors are pouring money into operational data analytics because they see the value. Today, I have the privilege of talking to you about DataOps, which is it's a relatively new term that sprung up sometime around 2014. And it helps us talk about collaboration in the context of data. If there's one slide you remember from today's talk, I hope it's this one. I'm going to help you out a bit. I'm going to show it at the end too. But the big idea here is that getting started with analytics data about your business is straightforward, and you're probably already doing it. You don't need a huge investment of engineering time. You don't need to purchase expensive software. You can and really should start small with the data that you already have. And finally, if your experience is anything like mine, most of the success you'll see comes when you search out people that need data and you help them get it. Before we really dive into it, I'm going to take a minute to introduce myself. I'm Steve Ross. I live in Pennsylvania, so hello from across the lake. This is my family. They also say hi. So here's some of my background to give you a sense of kind of where my professional perspectives are coming from. I started my career as a program manager at GE, and then a product manager at Microsoft, working mostly on web analytics. I was a software architect for a couple next-gen antivirus security companies, Mandiant and FireEye. And most recently, I was data engineering manager at Endgame Inc., also an endpoint security company. You can tell all the security companies up here because I think it's required that if you work in cybersecurity, your logo has to be big red. Endgame was recently acquired by Elastic, the company behind Elasticsearch. And so now I have the privilege of leading the security data engineering initiatives that are there. I'm also a proud DevOpsDays attendee, and I was lucky enough to help organize the DevOpsDays DC conference in Washington, DC. So here's the short and sweet definition that I'd give for DataOps. It's the cross-functional, collaborative principles of DevOps applied to data analytics. But I also want to get this out of the way at the start. DataOps is kind of a buzzword, a lot like DevOps or Big A, Agile. It's often built up to be this really big thing by companies that are trying to sell you something. Really, DataOps is just a different perspective on the same principles as DevOps. If you collect and analyze any operational data about your internal IT services or public web services that you host or software that you distribute, you're already doing the core of what DataOps is about. Today's talk is partly about Endgame. I'm sorry to disappoint you if you heard Endgame and you thought that it was going to be a talk about the movie industry, but it's actually not about that Endgame. It's about this Endgame, an endpoint security company, again, that's recently acquired by Elastic. But before that, it was a small startup with just a few dozen engineers. So this talk is focused exclusively on our time as an independent startup. I love Elasticsearch. I'll happily talk about it with anyone later on, but this talk is focusing on our experience as a small company. Today I'm going to talk about how my organization kind of stumbled upon DataOps accidentally as we grew up from being a small startup. I'm also going to spend a few minutes sharing some technical design tips that we learned along the way, mostly by trial and error, and also some lessons we learned partnering with other parts of the business to help them use data. And I'll finish up sharing a few challenges that we encountered, and maybe we can chat about those later on. So what started as a practical initiative for us to bring better reliability and visibility to our software actually had the unexpected effect of catalyzing a transformation that helped our organization become more data-driven across the whole company. It started about 3 years ago when Endgame began selling its software as a hosted service. We make and sell a security product that does real-time malware prevention across major operating systems. So naturally, we built up some basic monitoring systems so that we could sleep at night and know our software was still functional. So our data journey started at the tip of the iceberg for us, which was a single operational metric, alert count. So our customers buy our software, they deploy it on every computer in their company, and we live and we die by the alerts that our software creates. Our users get really angry naturally and may even uninstall our product if we create a really large volume of alerts for things that aren't actually malicious activity. No one wants to come into work in the morning and see 10,000 alerts because Windows Update did something that our detection algorithm happened to think was malware. So the first thing we ever did to monitor our software was collect information on alerts being generated in customer deployments. We actually did this before even building the basic monitoring you might expect, like service health or disk usage or that sort of thing. Really, our only concern at the beginning was ensuring customers weren't being inundated with bad alerts. On a technical level, we were doing that with what I like to call analytics hunting and gathering. We had our software deployments out in the world, and we were manually retrieving tarballs of alert information from high priority customers by SCPing them off the box or sometimes even over email. Then we'd manually review the data with grep and JQ to find places where our software was failing. And I think this is pretty much the lowest bar for operational monitoring that I can imagine. But by the way, if you haven't used it, I highly recommend the JQ shell tool for parsing and analyzing JSON. Also, I should mention that at this time, we did experiment a bit with setting up something more heavyweight. We tried Splunk, but the free tier limitations on ingesting log data are annoying. We tried Elasticsearch, but it was too much power, a little too early for us. We weren't really sure how to use it. So we stuck with the manual approach for the most part. And as engineers, we were primarily concerned about the workings of the software itself. And we looked at metrics through that lens. If alerts were wrong, our next steps would be immediately to investigate, change some code, and ship a fix for it. So maybe our malware detection engine needed a tweak, or we had to whitelist some company's software, those sorts of things. But we saw early on that other people in our company, even seeing this small slice of data, had different reactions to it. So our sales team in particular keyed into this alert data as a leading indicator for closing specific deals and for customer retention. So if a customer, either by evaluating our software in pre-sales or buying it in post-sales, experienced unusual alert spikes, they were probably having a poor experience and were at risk for purchase or for renewal. This risk existed even if there was no obvious bug in our code. Getting a large alert spike for them for any reason could cause customer dissatisfaction in the context of a sales cycle. So while we and the engineering team were working on improving the code, the sales team could use the same data to identify high-risk accounts and apply additional attention to helping those customers be successful. We really needed the sales-minded folks to discover this. And here's a chart that kind of explains why. So this is a representation of alert counts per day per customer over the course of a week. The blue line on top is our global total, and the other lines below are broken out by customer. As an engineering team, we would notice the big spike that happened late in the week. Several customers, including our biggest ones, all saw something go wrong at the same time. This would definitely get our attention, and we'd go investigate. But if you look at the bottom line for user D, I added to this chart a dotted vertical line for when this user started a trial of our software. If you look really closely, you'll see that shortly after they started the trial, there was a little spike of alerts. It's relatively small. So as engineers, we normally wouldn't even know about the timing of a trial, but the sales account manager would know that. And looking at this same data, they'd likely key into that and know it means someone should follow up with that user to make sure they're having a good experience. So armed with this new discovery about how our operational monitoring could be used by the business, we did what any self-respecting engineering team would do, and we over-engineered the crap out of it. We thought if one metric is good, we should have 100 metrics and be truly fantastic. Let's forget weekly data dumps. Let's get real-time data from everywhere all the time. Let's get some big data tech like Kafka or Hadoop or something like that. We read a bunch of articles. We watched some tech talks about real-time stream processing systems. And we got all excited about being on the cutting edge of data analytics. So we fell headlong into the second system effect. So we over-engineered a new data telemetry system that we thought would be better in every way. And if you have any experience going through one of these second system projects, you'll identify with the high risk of the project becoming bloated, late, and unusable. This diagram is the big data second system that we built. Our product installations in the field would establish long-running HTTP2 connections to our servers, because why not HTTP2? We'd load balance the traffic into a Kafka cluster. Then on the other side, we built a bunch of microservices in Go that would process the data messages and trigger actions into a Postgres database and also into Slack. We also put Metabase, which is an analytics web UI on top of Postgres. I'll come back to that in a few minutes. And on top of that, we put time series analytics data going via statsd into Graphite with Grafana on top. We got a little distracted with the design of this new system. And in retrospect, we were overly optimistic about the scale of the data we needed to collect. Also, we heavily overvalued post-processing data in real time with a high degree of flexibility. And we built the capability to do this before we had committed customers of the data. We were able to build metric dashboards all day long, but we quickly found ourselves grasping for some kind of practical use cases for the operational data we were collecting. Thankfully, this wasn't a complete failure. We did succeed in expanding the kinds of data that we collected over some of the common things you might expect for operational monitoring of an IT system. How many computers were we installed on, what operating systems are being used, what browsers do our customers use to log into our console, our web requests succeeding and failing, those sorts of things. So at least now we actually had this information. And thankfully, we had a few enterprising engineers in our team that had some really great ideas about joining our otherwise boring operational data with interesting business metadata. So naturally, these folks worked straight around our slick new stream processing system and went back to good old SQL and cron jobs to pull together our usage and performance metrics with information about what actual customers were experiencing those issues. Joining this data brought together some new and unexpected value for us. For instance, we filtered these security alert trends to our pre-sales customers. Like I mentioned earlier, we learned that pre-sales customers tend to install our software on very few machines, so their alert volumes are generally far lower than our larger customers. This time around, we had some folks load customer data into the same Postgres instance as our alert data, so we could easily filter down to just our pre-sales customer sets. From an operational perspective, we in engineering wouldn't have noticed a small spike of alerts, but now our partner in the sales team could directly filter for that and get alerted about customers that they cared about. Similarly, we started collecting HTTP logs about request success and failure on our web services. Our engineering team was only notified when failure rates spiked or when overall volume suddenly dropped, but our product management team used the same data to check on feature usage for specific services. We sliced HTTP logs in such a way that we could see activity across different features of the product and join that information with customer data across industries and across customer size to get a better understanding of when and how certain subsets of our user base were using new features. And on the far end of the technical spectrum, our data scientists that worked in the research group were able to pick these same HTTP logs and experiment with ways in which they could use the behavior of our current users with machine learning to build recommendations engines for new users just getting started with our software. This use case is particularly notable for me because our data scientists often preferred analyzing large batches of activity logs while experimenting with new algorithms, which was the exact opposite of our real-time streaming design. In almost all cases where our new improved data analytics system was successful, it was because somebody joined our operational data with another team that had a different perspective and other useful metadata that we could attach to the operational metrics. Also, every one of the examples I gave emerged from a single person accessing our operational data and experimenting on their own. Despite our best efforts to design some fancy stream processing system where people could check in code that would integrate with our real-time data stream, everyone took the more practical approach of pulling data relevant to them and processing it on their own schedule when they needed it. The other thing we learned was that the actual volume of data that we collected was pretty small. We definitely started off chasing after big data windmills, falsely assuming that our data would only be useful once we had 300 petabytes of it. In the end, today, we collect only a few megabytes per customer per day. One person binge watching Netflix series all afternoon would use way more bandwidth than we do collecting data from hundreds of customers, each of which can have thousands of machines running our software and reporting back telemetry data. So our little data actually turned out to be really valuable for the business. We were able to hone our more successful use cases, and our operational monitoring and analytics system today doesn't look at all the way I expected to when we first made the design 2 years ago. The system we have today is focused much more on quickly getting data to the people that know how to use it and giving them usable tools for exploring that data. We still have the same data transport that we built using Kafka and Go microservices, but honestly, it's heavily underutilized, and most of our value comes from new places. Several Jenkins jobs that extract business data from Salesforce and other places and insert it alongside our operational data in Postgres. And many enterprising people from other teams have built up ad hoc integrations with Python and cron jobs and bash scripts to pull out the data when they need it. We never set out to build anything like business intelligence. We were honestly just concerned about keeping our software alive and not losing customers over really bad bugs. We stumbled into analytics on business metrics that were useful across the company, thanks really exclusively to individuals who saw the data and had new ideas about how to use it. So in our experience, the concept of DataOps is intrinsically connected to DevOps itself. If you're committed to cross-functional, collaborative approach to building and shipping software, you can apply that same approach to analyzing and improving your company with data. And if you're interested in doing that, I encourage you to do it in 2 steps. First, pick technologies that enable access and exploration to your operational data. And then second, spread your data message to other teams by partnering with them and enabling them to be successful with the data you have. So first, let's take a look at the tech side. In our journey, we had some failures that slowed us down, but thankfully, we overcame those with just a few successes. Often, when I think about our small product company in relation to Google or Facebook or Amazon or Microsoft, I often think of myself like the little elephant in this picture, looking up to these big, huge companies that really have it all together and should be technical role models. In many ways, this can be true. Ryan talked about this yesterday, how we can learn from Google's SRE practices, for instance, but it can also lead you down the wrong path when choosing tech for your projects. We fell into the "you are not Google" trap. Our system was designed for much higher scale than we ever actually achieved. To be fair, as a small startup, we really didn't know what the future would hold for us. But on the other hand, our approach to build out a Kafka cluster with Golang microservices on top was definitely better suited to a system with 10 times the number of engineers and 100 times the traffic levels that we actually see in practice. Early on, we started dumping our data into a Postgres database as a stopgap until we had a better data store. It turns out relational databases are actually pretty great. This is the actual SQL we use to create one of our tables that stores the alert data I talked about earlier. we're able to use just a few columns and rely on the JSON column type to store semi-structured data in Postgres and then get the best of both worlds in our data storage. Good data consistency and also unstructured data storage when we needed it. In a way, our focus on tech choices also made us miss the second point at first, which is self-service. Our first time around, we dashboarded our operational metrics in Grafana on top of a Graphite database. We really like Grafana for time series visualizations. We still use it today for monitoring our basic system statistics like CPU, memory, disk, et cetera. Unfortunately, very few people know how to write Graphite queries. And it takes some dedication for new engineers to learn. Now, once you learn it, it's a very useful skill for time series analysis, but it's very unlikely that anyone in other departments, like sales or product management, will be able to engage with the data. Graphite queries are a little bit esoteric, and even the Grafana query builder can have a bit of a learning curve. So when Grafana failed to take off, we tried again using Metabase on top of a Postgres database. So Metabase is a free open source web app that's designed from the ground up to get people easy access to business data. This is a quick view of the page in the app where users can start with their own kind of data exploration experience. We saw two immediate benefits from using this kind of tech. First, deploying a usable point-and-click application that allows people to make and share reports without code does wonders for engaging less technical people. And second, a lot of people know a little bit of SQL. Allowing people to write SQL queries on your data is a great way to engage a broad range of people that would otherwise be too busy to learn a new language or write a whole microservice to do the analytics they need. And this was a really hard lesson for me to learn. Our current system today has some amazingly complex SQL queries that people built up over time. We're talking like thousands of lines of SQL in a single query. And so I originally balked at this. As a software architecture purist, I thought you should write a Kafka consumer in Go to pre-process the data. You should build better indexing and materialize views. But in the end, I kind of finally got out of the way and let people just use the data for what they needed. And I was actually really amazed at the results. Early on, we picked easy time series metrics to collect and analyze that really turned out to be vanity metrics without much value on their own. So these are things like total HTTP request volume, total number of our endpoint security installations, CPU load for our API gateway servers. As much as it's really fun to say how many million requests per day you handle, anyone that specializes in observability will point out why we got so little value out of this. They're gross aggregations of activity in our system. In reality, that activity exists in many, many different dimensions that we were losing. Thankfully, when we collected this data, we stored the unstructured metadata along with it, so it later on could be joined with other business data. So easily joining the operational logs with business context brought out the valuable insights that other teams could use to truly measure where we were succeeding and failing. Like the example I gave earlier with the customer alert spikes. So ultimately, we've used low-level metrics like resource usage on VMs very, very little. Annotating logs and metrics with unstructured metadata is what's really opened up the most possibilities for joining with other business data sources. As a software engineer, I tend to focus a lot on technology choices. But I've seen that making data useful requires a relational approach just as much as a good technology choice. A really great way to expand the reach and value of your monitoring systems and your system reliability projects is to partner with other teams, understand their goals, and then adapt your data to help them succeed. I'm sorry that this photo doesn't have as good of an analogy as the last one with the elephants. I just really liked it, and I put it in anyway because it reminds me that teamwork is universal. We're an enterprise software company. So that means our sales team faces a lot of pressure to get the word out about our product and help customers succeed. IT procurement is very complicated, and it's very different for every company. So our salespeople are exceedingly busy learning about individual customer needs and helping them use our technology to its fullest potential. In practice, data analytics can be transformational for pre-sale cycles and in enterprise software, helping better understand specific customers and tailor the solution to them. This value spans the whole customer lifecycle, from trials to renewal and retention, and even to upselling or cross-selling existing customers to become larger accounts over time. At pretty much every single point in the customer journey, it's a huge boon to have some insight about how they're using your product. Unfortunately, Sales teams often miss out on this value because they aren't staffed to develop the underlying data collection integrations with the software they're selling. This is the perfect place for the DevOps practitioner to lend their knowledge and their monitoring infrastructure. Standard operational metrics like web requests, login histories, deployment logs become extremely useful if they can be joined to customer metadata stored in a sales system like Salesforce. Is this user in a trial? Are they near renewal? What industry are they part of? All of these dimensions help sales teams see the operational data in a light that they can use for situational awareness. Customer support teams are often in a very similar position to sales teams. They're incentivized to handle the biggest fires quickly, and then they're understaffed to develop longer-term enabling technologies and systems. We've found that specific customer support requests are much easier to triage when we can couch them in better baseline data about other similar customers and the overall performance of our software. Being able to isolate data for a single customer and compare it to the bigger picture can help quickly identify anomalies in the context of a single support issue. Troubleshooting software bugs in the field is a master's class in filtering out signal from noise. And we found that customer support specialists are often the most skilled people in the company when it comes to quick pattern matching and debugging skills. This makes them the best suited to take advantage of self-service data applications that give them the freedom to investigate issues and compare data. I should note, though, that this doesn't take away from the fact that we, as the engineering experts, have a responsibility to make that data usable and make it available. The great thing about monitoring is that almost any operational metric can be slightly adjusted into a measure of customer engagement and of feature usage. Changes in request volumes and types might be responses to new features or changing customer needs. And naturally, you need some threads of data to connect your performance metrics to groups of users or to specific features. But we found that we often don't need to predict those correlations in advance. In practice, our HTTP logs, are a treasure trove of data for people with some inclination toward grep, maybe awk, and sometimes a little Excel. Product management are the most likely to come up with ad hoc questions that require looking back over large data sets. They often don't know what questions they need to ask ahead of time, but need to do investigations in the context of researching new market opportunities or improving existing customer experiences. So a really great way to partner with these folks is helping to extract that user group or that feature context from existing data that's been stored over time. Senior management often has trouble getting at real, accurate data about really anything in the business. If your company has KPIs or some kind of goals for the year, do you know how they're being tracked? You might find that the operational data tools that you use in your IT systems are actually the best the company has at its disposal for any kind of reporting and data analytics. This past year, we were able to help track several internal goals that we had as a company around customer growth and adoption based on our operational metrics, tracking request volume and deployment logs over time. Now, senior managers are usually the least likely to deep dive into a self-service tool. So be prepared to take a little more time to understand the data they need and polish up some reports. But on the other hand, they have the most opportunity to help spread your data message to the larger company. They can help sponsor projects and connect you with other teams to get even more value for the data that you have. OK, so the last thing I want to talk about before finishing up is some of the things that we're still learning and exploring. I don't want to present myself here as like the expert and having all the data analytics answers. In fact, on the contrary, I actually feel like we're just barely beginning to learn how to swim in this really big data ocean. So if nothing else, I hope you can take away from today some encouragement from our story that you can get started without really knowing what you're doing and kind of end up in an OK place. So a few things have stood out to us as challenges that I think are really inherent in data ops. The first is data governance. Maintaining customer trust and acting responsibly with the data we have is extremely important. Personally, I think it's a challenge of our time to work through the ethics of storing and analyzing data about people. So as soon as you take your operational data and join it with customer or user information in a way that might identify them or trigger some kinds of privacy regulations, that rightfully so brings up really important needs to technically manage access and usage of the data. A particular challenge to this aspect as well I think, is that the steps you need to take to manage your data is very specific to the business and the kinds of data that you have. So I think that precludes oftentimes using off-the-shelf tech to immediately solve this problem for you. For our use case, we've ended up developing a lot of custom code to properly anonymize and handle our data. The second is testing. So to test a data analytics pipeline, naturally you need data. So whether it's test data sets, redirecting some production data to staging systems, testing in production with the intent to roll back on failure, there's definitely added complexity to testing your code in systems that move and analyze data, since they'll often only break in the presence of that data or fail when handling your production environment. The third is productization. In my view, the ultimate application of DataOps is a data pipeline that can gather information about an IT system, analyze it, and modify the customer experience without direct continual human intervention. This is why I was really excited about the application I mentioned earlier, where our data scientists have built recommendations engines based on customer usage. That said, one of the big reasons this is in the challenges section is that it's very hard, in my opinion, to build full circle data pipelines without accidentally introducing bias or some other kind of systemic failure that automated systems may not be able to detect. So we've treaded pretty carefully on rolling out these kinds of features. So here it is. I promised I'd show this slide again at the end, and here we are. Our team, we learned that existing DevOps initiatives are often the best suited to spark a new focus on using data anywhere in the business. Partners with the right business context and curiosity are able to capitalize on really small incremental improvements to our data collection and analysis tools. By making our data available and accessible, DevOps practitioners can become critical enablers of the business and support teams across their org. If you'd like to learn more, a few resources I recommend. First, the ebook, Creating a Data-Driven Enterprise with DataOps. It's a thorough discussion of this space with really interesting case studies. Second is an often cited blog post, You're Not Google. I'll give you one guess what that's about. And third, a fun and really insightful talk actually about DevOps buzzwords. And I'm going to tweet these links after the talk so you can get them there along with the slides. And that's it. Thanks for your time. You can find me on Twitter at SteveWritesCode. The DMs are open, and I hope to chat at open spaces with y'all. Thanks again.